Hey guys, it's Ms.Tarango. In this video, we'll be going over compound interest and continuous interest. First, we have our formula for compound interest, which is A is equal to P times 1 plus R over N to the power of N times T. Now, our A stands for total balance. Our P is our principal amount or initial amount. Our R stays the same from last video, which is our rate. The N is the number of times compounded in a year. And another one that stayed the same was T, which is our time. Okay, now we can go ahead and go into our very first example here. Now, for our very first problem, we have Dave invests $300 in an account with a 5% interest rate. If he makes no other deposits or withdrawals, find his account balance after 15 years if the interest is compounded with the following frequencies. So we're going to do this twice. So here, we're going to grab the stuff that we're going to be using in both A and B. So here we have our $300 that he first invests with. So this is our principal amount. So off to the side, I'm going to label P and give it $300. And it's going to be in an account with a 5% interest rate. Now, this is going to be our rate, and like we did in the other video, we have to make it into a decimal again. So we are going to take 5, and we are going to move our decimal 2 times over, leaving us with 0.05. Now, let's see what the rest of this tells us. If he makes no other deposits or withdrawals, find his account balance after 15 years. That right there is our time. 15. And then now we need to figure out what our compound is. This is going to be our N. So our N for A is going to be 2 because semi-annually is going to be only twice a year. So here we can plug it into our equation being A is equal to P times 1 plus R over N to the power of N times T. And we have all of our variables here except for A, which is what we're looking for. So A is going to be equal to 300 times 1 plus our rate of 0.05 divided by our number of times, which in this case is 2, to the power of our number of times, which is 2 times our time of 15 years. Now this, if we were to plug this into our calculator, we should be getting... Okay, after plugging that into the calculator, I got 629.27. And this would be in dollars. Oh, I don't know what happened to my pen. I accidentally moved the size. Okay, let's try that again. That'll be $629.27. Okay, perfect. Now let's do it for monthly. Now we have 12 months in our year, so our N is going to be 12, and we're going to use the exact same formula. Now the only difference is our N this time is going to be 12. So it'll be A is equal to 300 times 1 plus 0.05 divided by 12 instead of 2 to the power of 12 times 15. Now this right here should give us, let me put it into the calculator and let me see what I get. Now I got 634.111, but since we're talking about dollars, we can only go to 11 cents. if we round, and this right here is what would happen if we compounded monthly rather than semi-annually, which you can see that there is a bit of a difference and monthly would give you a better rate. But let's go ahead and move on to number 2. Okay, here I'm going to set up part of it, do A with you guys, and then I want you guys to go ahead and try B on your own, and while you're at it, try 3 as well. But let's go ahead and get into it. Here we have 2,500 deposited into savings. Now this right here is going to be our principal or our initial amount. So off to the side, I'm going to write P is equal to 2,500. And into that savings account, we are earning 8% annual interest. So this right here is our rate. So for 8%, if we move our little decimal over twice, we end up with 0.08. How much will be in the account at the end of 25 years? So this would be our time, T, 25 years. Now, if it happens quarterly, this would be 4. There's 4 quarters in a dollar, if that helps you remember. And our equation is going to be the same thing. A is equal to P times 1 plus R over N to the power of N times T. A will be equal to, our P in this instance would be 2,500 times 1 plus our rate of 0.08 divided by our number of times compounded would be 4 to the power of 4 times our time, which is 25. Now, after sticking all this into our calculator, we should be getting, I ended up with 18,111.6. Okay, perfect. Now, I want you guys to go ahead and try B for number 2 and number 3 all by yourselves. I know you guys got it. Good luck, and pause the video. Okay, guys, so you should have gotten $18,468.58 for our daily calculation on number 2. And then for number 3, we had to do a little bit of extra here. We have Amelia turning 6 and her grandparents opened a college savings account for her, and she can access this at age 18. That is why we had to subtract 18 by 6, and that's where we got our 12 from. Now, bi-monthly can mean 2 things. So in this case, we did mean 2 times a month, not every 2 months. And I know that can be confusing. However, I hope that this does not come up again. Now, for our P, we ended up with $500 as our initial deposit, and our rate was 0.032. We had to convert our percentage to a decimal, which you can just divide by 100 or move our decimal place 2 times to the left. And then we plugged everything in, and we should have gotten $733.88. Okay, now we can move on to number 4 here. Now, number 4 is a little different because of what it's asking for. It's asking for our interest rather than the total amount of what we made. So while we still need our total amount of what we made, we are then going to subtract it by our initial amount to see how much interest we made in this account. So first and foremost, we need to figure out what all of our variables are. So let's go ahead and do that while we read our problem. So suppose the savings account offers a 0.4% interest rate. So we already found our rate. Our rate is equal to 0.4%. However, we need to have it in decimal form and get it out of that percentage. So let's move our decimal two places to the left. 1, 2. So we end up with 0.004 as our rate. And now we can continue reading. This is compounded semi-annually. Now, if we remember semi-annually from before, this is going to be 2 times. So our in this time is going to be 2. If Samantha opens an account with $750 and makes no other deposits or withdrawals, so this right here is our starting point. This would be our P. So $750. And now we have our time left. How much interest will she have earned after 10 whole years? Okay, now we have everything ready to set it up, and we are going to plug it into our equation. Our equation is still the same for this one. A is equal to P times 1 plus R over N to the power of N times T. Now our A is equal to 750 times 1 plus our rate of 0.004 divided by our N of 2 to the power of 2 times 10 being our time. Now our A is going to equal, let me go ahead and put this into my calculator and we'll see what we get. Okay, so I got 780.58 with rounding, of course, because we have to go to the nearest penny, and this would be in dollars. And now we haven't quite answered our question because it's asking for how much interest she would have earned. So we're going to take what we just found, $780.58, and subtract it by our initial amount, which was $750. This right here should give us $30.58 of interest. And that's our final answer. Okay, and with that, that's a few examples using our compound interest. Okay, now we're going to talk about continuous compound interest now. Now this formula is a little different. It's going to be A is equal to P times E to the power of RT. Now E is like pi, it's a set number, so it is not just a variable. So if you put in a variable into your calculator, you are going to get an error. You have to use the proper E. It is equal to about 2.718, and then so on and so forth. Just how pi is 3.14, so on and so forth. Okay, so now that we got that out of the way, we're going to now try a couple of examples using this new formula we have. So we're going to start with number 6. Suppose $800 is invested in an account at a 6% interest rate, compounded continuously. If no other withdrawals or deposits are made, find the balance in the account after 20 years. Now, this compounded continuously right here is very necessary whenever we're not doing notes because it's going to tell you that this is the equation that you are going to need to use. So $800 is going to be our P for this case. And it gives us a 6% interest rate. So this right here is going to be our rate. We still need to convert it to a decimal, however. So it'll be moved over to decimal places, leaving us with 0.06. If no other withdrawals or deposits are made, find the balance in the account after 20 years. And this right there is our time. Now we have all the variables that we need to find our A. A is equal to PE to the power of RT, RP being $800, E to the power of 0.06 times 20 as our time, leaving us with the A amount of $2,656.09. Okay, perfect. Now I want you guys to go ahead and try number 7 without me. Okay, so for number 7, you should have gotten $2,241.90. So for this one, our time is 5 years. Our initial deposit or investment is $1,200 and our rate was 0.125. Okay, now let's go ahead and move on to 8. Now we're going to notice a couple of things about 8. So on number 8, we have our initial investment, we have our time, but it's asking us to determine which interest rates and compounding periods would be her best option. So we need to say option A or option B is better. It'll give her more money in the future. Um, so here we do have our initial investment and our time. Okay? So these are going to be true statements for both option A and B. However, option A has annual interest compounded monthly. So for this one, our equation is going to be, so for option A, it's going to be A is equal to P times 1 plus R over N to the power of N times T. We already have our P. Ooh, I should put it off to the side. As 1500. And our time is equal to 30 years. Now, for option A, we are going to have a rate. So, hold on. Option A will give us a rate equal to 5.5%, which is really 0.055. And this is going to be compounded monthly. So we will have an N equal to 12 in this case. Okay, now we can plug everything in for just option A. We would end up with A is equal to P, which is 1500 times 1 plus our rate of 0.055 divided by the number of times in a year, which would be 12, to the power of our number of times in a year, 12, times our time of 30 years. Okay, if we were to plug all this into the calculator, we should end up with $7,781.08. Now, option B is telling us that it's a 2.7% annual interest, but it's compounded continuously. So since it's saying that it's compounded continuously, our formula for option B is A is equal to P times E to the power of RT. So here, we don't have an N to use, and the only thing we really need is our rate. So for option B, our rate is equal to 2.7%, and if we move it to find our, if we move our decimal 2 times to the left, we'll end up with 0.027. That's the only thing we really need because we have our P and we have our T, and those are the only variables we need to look for. So A is equal to 1500 times e to the power of r at 0.027 and our time of 30. Now if we plug all that in, our A is equivalent to $3,371.86. So we can definitely tell which one's bigger. In this case, option A will yield more money. So to let her know which is the best investment, we would tell Carla that option A yields more money. And this would be our final answer. And thank you guys so much for watching this video and learning with me. I hope you have a wonderful rest of your day. Bye.